When a linear function rule is written in the form f of x equals m times x minus h, that h parameter shifts the graph of the function left and right. In this top set of examples, we're going to be comparing g of x, both versions of g of x, to this initial function f of x equals 2x. This is the graph through the origin with a slope of 2. It's a little steeper than the parent function. When we have an h that is being added, in this case g of x equals 2 times x plus 3, that plus 3 is going to do the opposite of what you would expect. When we have addition, when we are adding 3, we are going to actually shift the graph left. So this right here, this graph that is shifted left, is the graph of g of x equal to 2 parentheses x plus 3. The big idea here is that that h does the opposite of what you would think. The plus 3 shifts the graph to the right. You can check this by doing the distributive property in your head and seeing that this can equivalently be written as 2x plus 6, g of x equals 2x plus 6, which has that positive y-intercept of 6, or we can think of it as having a k parameter of plus 6 shifting up. All right, and then similarly, when we have a minus 4, that's going to do the opposite of what you think, and it's going to shift the graph right. So we're going to shift the graph 4 units to the right, 4 units to the right. That means that g of x equal to 2 parentheses x minus 4 is going to be this graph right here. And similarly to what I talked about above, we can use the distributive property and see that this can be written as the equivalent equation g of x equals 2x minus 8, so shifted down 8. The same left and right pattern that we talked about will happen even when m is negative. So here we have j of x equal to negative 3x. This has a slope of negative 3, steeper than that parent function, and steeper than the graph of f of x equal to negative x. When we are adding a number to the x inside parentheses, adding a number, that's when we are going to be shifting the graph left. So this is going to be shifting the graph left 5. So we're looking at this graph right here. We can check with that distributive property. We would have a negative y-intercept, a negative vertical shift, a shift down. So that leaves L of x to be this graph right here, shifting 5 units to the right. We are shifting to the right. Using the distributive property, we would have a positive y-intercept. This is a really tough thing to put in our long-term memory, that when we are adding a number, we're shifting the graph left. When we are subtracting a number, we are shifting it right. So this is a great time to use Desmos, make a prediction. Let's see how the graph of 3 parentheses x minus 1 will look. I think it will be shifted to the, what's my prediction? What's your prediction? Minus 1. It's going to go to the right, and yep, I was right. So make that sort of prediction. What if I add 6? What's going to happen? Make a prediction. Adding 6 to the inside of the parentheses. My prediction was that it would go left, and it did.